everybody? Welcome again to Coffee Hour. My name is Paul Abernathy, your host, and EV Mux was having all kinds of problems. But looks like we're back going, or at least we're back going. So, anyway, we're going to do something today anyway, regardless of whether EV Mux likes it or not. We're going to be doing it. So, I don't know if it's working on the other platforms, to be honest with you, if it is streaming or not. But either way, we are here. And let's see here. Yep, looks like it's working on the other platforms now. Hey, folks, thanks for joining me. It is Wednesday, the 22nd of October. Thanks for joining me. For those out there who are not familiar, my name is Paul Abernathy. I am the host of Coffee Hour. Also, I'm CEO and president of Electrical Code Academy, and we bring you the electrical training courses. And if you happened to just a minute ago on the stream and it disappeared or I wasn't there, you can blame EV Mux. You don't have to blame me. Okay. So blame them. But good morning. Glad to have you here. For those that stayed with us, that joined us, I'm going to continue on whether or not I have, zero people watching because it's just what I do. Okay? I teach the code and talk about the code and don't worry about all those little details and we'll just fix them as we go. How about that? All right. So on today's episode, we are going to be talking, or I'm going to be talking about underground installations. We're going to be covering more specifically 300.5 of the National Electrical Code, which is the underground installations. Okay. And so that's what we're going to be focusing on today and looking at the table 300.5 as well and talking about that. We'll also take a quick look over at NEC Quiz so you can see what's going on with NEC Quiz as well. So you can see what's changing there. And I'll talk about a few updates that we've made so that it's a little easier for you to view things on the mobile device, that type of thing. And again, for everybody that was on here, we dropped you. We're back on it. So over on TikTok, it's back up. It's live. Should be live. That type of thing. But again, it lost it earlier. And again, you can blame EV Mux for all that. Seems like everybody that's watching is actually over on Fast Tracks Tube. So it may not be working over on our other platforms. Type of thing. I'll probably go look. And if it's not, I probably will just kill the stream and is what it is. So looks like it's live over there. So I don't know, maybe it's just the ingest is just slow and it's not working. So either way, it is what it is. Okay. All right. So let's go back here. I don't know that it's working. Here, let me go real quick. Check it, make sure. It says it's live. I doubt it is live. Let's see. Okay, it's working. So, all right. Anyway, enough of that. I don't care about what the numbers. See, the thing never shows me the right numbers of people that are watching anyway. So it's always different, So anyway, thanks for joining me in here at Coffee Hour. All right. So let's talk about real quick. Let's do some shout outs to those that are here that I can see. If you're here, let me know in the comments, whatever platform you're on, and I'm more than happy to share. What is up, Rob? Says it's on Fast Tracks Tube. Our irony is that it's running fine over there. What's up, David? Good morning. Glad to have you here. And Rob's doing that hashtag win to get in on the spin. Okay, so we combined the quarter 3 and quarter 4 together. So you can still get in on that if interested in it. Okay. All right. So again, don't know who's watching where. My numbers aren't going to line up anymore because it's just not working. But it's okay. We'll just keep going. All right. So let's go on and look at today's lesson. Actually, let's go on and look at the NEC first, and we'll do that. So here we're at the NEC 300.5 underground installations, and probably the first aspect that people run into that they find the more complicated portion of is how much cover do I have to have on the conductors or the cables that I bury, right? So that's probably the one of the questions I get in a lot of videos that we see online, and they'll post their installations and they'll show their trench. And you look at it, and everybody comments and goes, "Really? I mean, there's zero cover on that trench, right?" So they're like, "What's the depth of that and whatnot?" So um, that's what we'll kind of look over at that again today and try to cover that topic. All right, so here we go, our minimum cover. So whether you're running direct burial cables like a UF cable, uh, direct burial conductors, for example, would be a USE-2, but you can get them plexed together in what we call URD or a UDC or underground distribution cable system. It's designed typically from the meter out to the pedestal underground. And that would be something they call, again, underground service entrance. And when we put it all together and plex it, we call it a URD, underground residential distribution. Some people call it underground rural distribution, but it's really underground residential distribution. And that is basically just made up of USC-2 conductors that are all plexed together or twisted together from point A to point B. That's all that really is. There's no markings, there's no UL or standard for um, the URDs or UDC or whatever your jurisdiction calls it. There's really nothing for that as far as a listing. It's basically just comprised of now what we call a cable assembly, and it's basically single insulated conductors that are twisted together. Now, you can't twist conductors together in the field and call it a cable, but manufacturers can twist it together, call it a cable, and then sell it to you. And so that's what we do with the URD, but it's really just USE-2 conductors, insulated conductors. So they're designed for direct burial. Okay. So when you see something like this, it says direct burial cable. That would be like a tray cable has the ability to be direct buried if it has a marking on it. So that would be a direct burial cable. UF cable, that's an example of a direct burial cable. Non-metallic sheet cable is not direct burial, obviously, dry location only, indoors, that type of thing. Um, what else? Other types of cables that you have a PVC jacketed MC. So PVC jacketed MC can actually be installed in the ground if it's rated for direct burial. All these type of things, and when you put it in the ground, you have to have a certain amount of cover. So one of the kind of the misnomers that people have is that they will say, if I need 18 inches of cover or 18 inches of a trench, they'll dig at 18 inches. But then they put the wiring method in there and don't realize that it's the depth of cover that has to be what 18 inches or 24 inches, not necessarily just the trench, right? So that's important things to remember. It's the amount of cover, and it starts from the top of the wiring method, top of the conductors, okay, to the surface, that type of thing. Right. So that's what we're talking about when we talk about depth of cover. Okay. All right. So let's kind of go to the lesson, and it looks like the lesson's not showing. So let me go on and re-show this. There we go. The lesson is now showing. All right, so the cover measurement commences from the top surface of any direct burial wiring method, conductor, cable, conduit, raceway, whatever. It's from that and the ends at the closest point of the finished grade's top surface, including concrete. Okay. So again, from the top of whatever the wiring method is, all the way up, and it ends at the closest point of the finished grade's top surface. Okay. And let's see here. Caution. Oh, by the way, all this information that we're looking at here on the screen is from your Fast Tracks program. So if you're already in the Fast Tracks program, this should be old hat to you. And this stuff should make sense to you. Raceways must enclose underground cables and conductors installed under buildings unless the wiring method is type MC or MI cable that is identified for direct burial, and that's in 300.5C in table 300.5A. We'll look at all that and some of this cover here. So we'll zoom in and I'll refer back to any of this as necessary so that it's totally clear. Right. So let's go on and go to the NEC. I like going to full page NEC real quick, and we'll get into these requirements first. It's chattering like crazy. All right. So let's go back before we get into that. Let's go on and get into. Bear with me here. Let me get into. Okay. So 300.5 underground installations, the minimum cover requirements that we have to have. Okay. And we just talked about it. And so this is the table. I'm going to see if I can pull up the table just enough so you can see the most of it. I'll move to where we need to go. All right. So this is your table right here. All right. So a couple things to remember. Locations of wiring methods and circuits. So on the left side of this table, you have all of the locations of wiring methods or circuits. So you have the very top one, which I think people will get confused about a lot of times when it comes to the National Electrical Code. The top one on the left says all locations not specified below. So if some type of installation that you're running into is not covered below here, okay? If it's not covered in here, then this is the column that you're going to fall in, the very top column, okay? Right, so here you see all those, and we'll look at each one of those. So this is your catch-all, okay? That's your very first thing. That's your catch-all. And I think that's the first thing when I'm teaching students that they have to grasp is that every installation may not be covered in all of the things that are underneath this. Now, we're looking at table 300.5, by the way, if you're following in your NEC, okay? So this is your catch-all, right? And then underneath that, you have the location of the actual wiring method or the circuit, okay? So here, in a trench below 2 inches thick concrete or equivalent, okay? So this is if I'm running the wiring method, whether it's direct burial cables or direct burial conductors, whether it's rigid metal conduit or intermediate, whatever I'm doing, if I'm running it under in a trench and I'm running under and it has 2 inches thick of concrete, then I have a reduction. See, the general rule is right here. But let's just use direct burial cables real quick, column 1. The general rule is all locations that are not covered below, it's 24 inches of cover. Okay, that's not 24-inch deep trench. Okay, that is 24 inches of cover from the top of the wiring method to the finished grade. Okay, so that's the cover. If I have trench and it's below and it has 2 inches of concrete or equivalent, right, to that, then I can have a reduction of cover. And in this case, for direct burial conductors, right? In that case, for direct burial cables and conductors, then I can have a reduced cover to 18 inches. Why? Well, because it has that 2 inches of concrete. Okay. So there's a reduction. So that's what that's talking about. There you go. That's for direct burial cables or conductors. Now, if it's under a building, right, then it's 0, okay, as long as it's in a raceway or type MC or MI cable identified for direct burial, okay? And that's what we saw when we came back to the lesson. That's what we saw when we read here, which says raceways must enclose underground cables or conductors installed under buildings unless the wiring method is type MC or type MI cable as identified for direct burial. So, okay, can I have raceways underneath the building and have 0 clearance underneath the building? Yes, I can, as long as it's in a raceway. And again, a lot of people don't realize that you most certainly can have PVC jacketed MC running under a building. Now, most people don't like that. They'll say they don't like it because they can't pull new conductors in it, so they want to run raceways. You also have to remember that underneath the building is typically the building is on a slab anyway. So if you're under the building, you've got the benefit of all of that slab, that type of scenario. Okay. So where you have that, you have those requirements. Okay. Under a building, you don't have any depth requirement because it is under the building. All right. Makes sense. Okay. And we'll stick with direct burial cables and conductors just as we go through this whole list here. So this makes it easier on us. The next one would be under minimum of 4-inch thick concrete exterior slab. Okay, so we're not talking interior slab. We're not talking about slab under building. We're talking about an exterior slab, but it has no vehicular traffic and the slab extends not less than 6 inches beyond the underground installation. Okay. So it is exterior. You're running your direct burial conductors or direct burial cable underground, outside, and you're going to be under a 4-inch thick slab of concrete that's not designed for any vehicle traffic. Okay, so maybe just a patio or whatever it was. So it's not for vehicles to drive on. Okay. If that's the case, and the part that runs underneath the slab, right, it extends not less than 6 inches beyond the underground installation. Okay. If that's the case, then I can have a reduction to 18 inches instead of 24 inches of cover. Okay. Next is under streets, highways, roads, alleys, driveways, and parking lots. And I will remind you, this would also encompass parking decks. Okay. It would encompass that as well. What's up, Jonathan? Thanks for joining. So that means if I'm going to run direct burial cables or conductors under a street, highway, road, alley, driveway, and parking lot. Now, again, we have some residential driveway applications. So this is just an in general. Okay. Obviously, if we have a 1 and 2 family, then we have other allowances, but this is in general. And again, I'll say this does encompass those parking decks that you'd see. Now, only the ground level. Obviously, once you get above ground, that's not an issue. Only the ground level and the slab. All right. So this is 24 inches underneath that. So in your parking decks, even though you have the concrete, if it's a parking deck, for example, the bottom level, that is obviously for vehicular traffic. So you're going to have 24 inches of cover. 1 and 2 family dwelling driveways and outdoor parking areas and used only for dwelling related purposes. So dwelling units, outside areas, things like that, park driveways for residential, all that. Then you have for 1 and 2 family, then you have a reduction to 18 inches. Again, we're talking direct burial cable and direct burial wire, like a USC-2, that type of. And then this one says in or under airport runways, including adjacent areas where trespassing is prohibited. So that'd be the airport runways and then areas around it, like the tarmac and stuff like that. Then that would be 18 inches of cover for direct burial cables and direct burial conductors. Okay. So that's kind of column one, but you kind of get to see how the structure goes. Now, the only difference here is as you move to the right, you have other different wiring methods. Right. So the thing about that is all you're really going to get here is same scenarios, same rules on the left, same locations. You do have your general rule that is 6 inches. So for if it's not in this list, it's not any of the applications in this list, and I'm just going to be running rigid metal conduit or intermediate metal conduit underground, then I have a general catch-all. It's going to be 6 inches of cover. So again, obviously it's much stronger. It's rigid or intermediate. Okay, they are subject, they can handle things like physical damage, that type of thing. So you have a reduced clearance. Just remember, this is 6 inches from the top of the wiring method to the finish. Okay, this is not 6-inch trench and then I just throw the wiring method in. Okay, this is measured from the top of the wiring method. So 6 inches there, here 4 inches. Now under this one right here, notice this is still 24. What is that? That is those parking decks. I remember back in Alexandria, the guys wanted to do a less of a depth underneath the parking garage because they talked about the slab and stuff like that. Now it's pretty clear here that under the parking deck, which is a parking lot, vehicular traffic and things like that would be on it. Then I had to have the depth of cover. And it stayed 24 inches. It didn't reduce that. Okay. So a lot of times they would mess up with that because there's a lot of parking decks, parking garages in the Northern Virginia area. And in the on the ground, got to be 24 inches down. Here you see again, let's go back over here a little bit. There we go. So intermediate, right here, you see the depth of cover. Now, right here, 4 inches. That is under 4 inches of slab on the exterior. Okay. With no vehicular traffic. Then when it comes to rigid metal intermediate, you don't have to be 6 inches of cover. It can drop to 4 inches of cover. Okay. And notice that even when you run rigid and intermediate down here for 1 and 2 family, notice that it's still 18 inches. Kind of interesting, right? Because it's still rigid and intermediate. Um, but you would think that I could reduce the depth. No, 18 inches. And same 18 inches for rigid or intermediate also when it comes to under airport runways and, of course, adjacent areas like tarmacs and things like that. All right. So that didn't change. That one's odd. Somebody should probably submit a change here because I don't necessarily think it probably doesn't need to be 18 inches for these locations here, but it is what it is, right? All right, let's go to the next one. Next one is here you see in the 2023 edition of the NEC, here we have EMT was added because EMT can be in locations subject to physical damage. Also, big, huge misconception that people have about EMT is that they think that you cannot bury EMT. You most certainly can bury EMT. In fact, from its listing, it already has an element of protection, a protective coating, that zinc coating that is already applied to the product. So it's rated for direct burial as long as you use proper fittings. And you can say, well, I don't like that. It doesn't matter what you like, it's what the code allows, and that is what it is. So you see it's clearly in the list in column 3. It's right there, EMT. Okay. Of course, also non-metallic raceways like PVC listed for direct burial without concrete encasement. And most all of that PVC product, PVC Schedule 80, Schedule 40, all that type of stuff is direct burial. And then, of course, other approved raceways, anything that the AHJ can look at. And if it says that it is rated for direct burial application, then the AHJ is going to give you that approval that's necessary. Got to have that approval, that type of thing. Good thing to remember is all wiring methods, whether it's direct burial cable, whether it's tubing, EMT, whether it's raceways like conduits, PVC, all that. All of those are required to have a listing. Okay, so all those wiring methods have to have evaluation done by a third party. Okay, so third party lists it, and there you go. And it's going to be labeled. Typically, it's listed and labeled, or both, when it comes to those products. So anyway, column 3 says, do we have any reduction? What about those depth of covers for those products? Okay, well, it looks like the general catch-all is 18 inches for these products. So if it's not covered by the column on the left, it looks like it covers. So if you're going to run EMT and it's not one of the situations on the left side, it's just a general use, then it looks like 18 inches of cover is all you need for that. Now, there is a reduction down to 12 inches here, and that is for if you're below 2 inches thick concrete, right? If you're below 2 inches thick of concrete, then you can get away with only 12 inches of cover. So top of the wiring methods, for example, top of the EMT to the finished grade, okay? And then 0 here means there's zero coverage or zero cover requirement under a building when it comes to EMT. Okay, 0 coverage. So the foundation and everything, the flooring and the slab itself is already sufficiently thick enough that I don't have to have any clearance underneath it. Okay, that's fine. Let's see here. What else? Let's see here. Hold on here. Going down the list. Okay, number 4, 4 inches here. This has to do with, let's see here. This is if you're under 4-inch thick concrete exterior slab. Okay, that's the case. And you would have 4 inches. Okay. 24 under the driveways, parking decks, things like still 24 inches there of cover. 18 inches is still here under 1 and 2 family dwelling driveways and outdoor parking areas used for only for dwelling related activities. Still 18 inches for that. Probably submit something and probably could change that. It's not, I don't know that it would be necessary. It seems to me if we can have a reduction for direct burial cables, you should, if you're going to put it in a wiring method like this, then you should have a should get a reduction, right? Seems like it would. I'm not going to rock that boat. And here again, 18 inches of cover here. And this one has to do with, again, airport runways and adjacent like tarmacs and things like that, loading area, passenger loading areas, things. All right, let's see what else we got. All right, okay. The next one is column 4. And this is residential branch circuits. Okay, so this one's the one that people see, so there's a lot of videos on TikToks and social medias where people are running these circuits out to a shed, little storage shed building, things like that. She shed, man shed, whatever your flavor. So this has reduction of cover under column 4. So this is residential branch circuit. So this is only for the residential branch circuit, by the way. The reason I point that out is because sometimes if you're running to residential detached structure and maybe you're going to put a panel in it, that's not going to fall under column 4, right? Because this is residential branch circuit. If I'm running a panel out there, I'm going to be putting a feeder out there. And if I'm putting a feeder panel in that detached structure, detached garage, or whatever it may be, then that's totally different. That wouldn't use column 4. Okay. So, and that would be, you'd use one of the other methods or, one of the other applications, but you're not going to be using, you're not going to be able to use column 4 for that. Now, this is residential branch circuits rated 120 volts or less. Okay. So that is very specific type circuits we're talking about. With GFCI protection. So it's got to have GFCI protection on that branch circuit. And the maximum overcurrent protection is 20 amps. So if I have a branch circuit for a residential application, maybe I'm just running it, just running some lights or receptacle at a detached garage or shed, then I can have a reduced clearance, depth, I guess. I only have to have 12 inches of cover, right? Is a general rule. So it's got to be 12 inches down. Okay, as long as it's GFCI protected, it's 20 amps or less. Okay, and it's a 120 volt circuit. There you go. I get a reduction in amount of cover. Now you go right here, you see it drops down to 6 inches. Okay, so that is if I'm going to happen to run it out there below 2 inches thick of concrete or equivalent. Well, who's going to do that to your detached shed? You're not going to do that. Unless, of course, your shed is maybe sitting on a driveway that is 2 inches or thick and you're running it under the driveway and the shed's sitting on the end of the driveway. I guess it's plausible, but for the most part, it's probably not. You're probably just running it through your backyard, right? So in that scenario, if it was under 2 inches of concrete or equivalent, then I could reduce the cover to only 6 inches. Okay. So for the most part, it's probably for most of you that run it through your backyard, you're going to be 12 inches. Now, I should remind people that nothing says that I have to follow column 4. This is just to get a reduction for this specific circuit. I most certainly would, if I could follow these other columns, if they were germane, like I'm running it in rigid or intermediate or what. I could do that. If I wanted to get that circuit down to only 6 inches, then I could come over here and use rigid or intermediate if I wanted, right? And I can drop it down to 6 inches. Or, like I said, or I can run a residential circuit like this, and it could be 12 inches. Where there you go, different choices. Now, the other thing is to say direct burial cable, UF cable. If it was under the general rules over here, same application, same 120-volt branch circuit, same GFC operator, all that, I could run it under column one because it is a direct burial cable, right? But I'd have to be 24 inches, except when I'm doing here, I could get down to 18 inches maybe and run it there, right? But why would I want to do that when I can go over here in GFCI protect it and it's not bigger than 20 amp and it's resistant, I can get 12 inches of depth that I have to be from the top of the cable assembly to the finished grade. Only 12 inches of cover. That type of thing. All right. Can I run it under a building? Can I run this circuit under a building? Yes, as long as it's in a raceway or it's type MC cable, and that's the PVC jacketed type, by the way, not regular MC. Okay, y'all know that. I shouldn't have to tell you that, but y'all know that. So I can do that as well. It's in a raceway, no problem, no cover required. And then of course you hear right here, I can do 6 inches for this application and then 4 inches if it's in a raceway. If it's direct burial for this one, okay, under 4-inch exterior slab with no vehicle traffic, just a 4-inch slab outside. Okay, well, if that's the case, and I'm running, and it's one of these 120-volt GFCI protected 20 amps or less branch circuit, okay, then I can reduce the depth of cover to 6 inches, or I can put it in a raceway and reduce it down to 4 inches. By the way, could I run UF and do this? Yes, I could. As long as I made all the parameters of this column, could I sleeve that in a raceway for that portion and make sure it extends, the concrete extends past where it comes out of the raceway? Absolutely, I could. And I could reduce it down to 4 inches if I want. Okay, that type of thing. I don't know why this grammar thing. All right, so there you go. So I have more options here. Uh, Probably vast majority of the time for everybody that's running these 120-volt, 20 amp GFCI protected branch circuits to outside, let's say to a shed or something like that, uh, or post light. That's a good example of post light. You're probably going to be 12 inches is what you're probably going to run the depth. So you're going to be digging it down. So you're going to be digging it so a little bit more than 12 inches. That way you got your depth of cover. All right, and of course you see here, I don't know when we would have these circuits right here run at an airport, but you could 18 inches of cover, that didn't change. One thing you'll notice is right here, 12 inches right here. So this is 12 inches too, and it is for 1 and 2 families. So you still have your 12 inches of cover for that under driveway. So just bear in mind, same as the general application up here. Same as the 12 inches general application. Let's go into the full view. Okay. And then, of course, again, if you happen to run those circuits under a runway, I don't know why you would, but if you did, 18 inches. Right. And then lastly, column 5. Now, column 5, a lot of you landscapers, landscaping folks do a lot of work around landscaping, things like that. You'll run into this. It says circuits for control of irrigation and landscape lighting limited to not more than 30 volts. Okay, so it's a 30 volt system. Okay, low voltage system. Okay, 30 volts and installed with type UF or in other identified cables or raceways. So when we say other identified cable raceways, you have companies, right? There's a company out there called AMP that makes a lot of landscape lighting, and there's other types of cables that are available other than just UF, right? So there's other different that are designed specifically for the application. So if that's the case, then their depth of cover for those products can vary as well. right? So when you look at that, you'll see that here that is 6 inches for the general application. But you notice these little footnotes, 1 and 2. And we'll go look at those in a second. But 6 inches of cover, right? Here under slab, okay, is 6 inches of cover. If it's in a raceway or MC or MI cable identified for direct barrel, then zero cover. You put it in a raceway, you're good. And then, of course, if it's direct barrel under 4 inch exterior slab, 6 inches of cover. Or if you put uh, that circuit in a raceway, then it drops it to 4 inches of cover. Still 24 inches under parking decks, things like that, driveways, other than 1 and 2 family. And then, of course, the 1 and 2 family is 18 inches. And, of course, runways and things like that be 18 inches. Okay. All right. So now let's look at that 1 and 2. So here's that 1 and 2 that it referenced. It says a lesser depth shall be permitted. So remember, it said 6 inches for that 30-volt circuits or less type of scenario. It says a lesser depth shall be permitted where specified in the installation instructions of a listed low voltage lighting system. So what does that mean for me and you? So that means if you buy your system and you buy the cable and it has instructions in there that allow you to be installation instructions that allow you to be less. Now, people say, well, you can't do less than what the code says. Well, the code says 6 inches, but it had those footnotes, and those footnotes send you down here to 1 and 2. They're very much part of the code, okay? Very applicable to the code. So it says, look, it shall be permitted. It's not required. I mean, if you can follow the code table if you want, put them down 6 inches. Remember, these are for those landscape lighting and irrigation. Then you could do 6 inches of cover. The thing about that is when you see this stuff in landscaping beds and things like that, you guys, electricians, are running this all the time. You know, daggone well, they're not putting this stuff down 6 inches. So typically, what happens is it's usually a much thicker type of cable, and it's direct burial, and it is way thicker than normal. And if you read the instructions from the manufacturer, whether it's like a Malibu, those companies, then they'll actually give you instructions. It'll tell you, and it'll say that it only needs to be down 3 inches or 4 inches, things like that. Okay. So you can follow their instructions. So it could be less than 6 inches. If the instructions aren't given on a depth of cover, then you follow what's in column 5 of 300.5, the table. And that's 6 inches for the general application. Uh, Number 2, it says a depth of 6 inches shall be permitted for pool, spa, and fountain lighting installed in a non-metallic raceway, okay, limited to not more than 30 volts were part of a listed low voltage lighting system. So this is allowing you to be 6 inches, okay, when you're dealing with certain types of the low voltage lighting, as long as it's in a non-metallic raceway and it is around swimming pool applications. Okay, so you may have some type of accent lighting that's around the perimeter of a pool, things like that, and it would allow for these 6 inches to be used where that type of wiring method may be typically much deeper based on the table, depending on what you're working with. So, again, it's going to be very specific around pool, spas, and fountain lighting, as long as it's installed in non metallic raceways and it's to not more than 30 volts. And all of that lighting is not just willy nilly, it's all part of a listed, okay, low voltage lighting system. If that's the case, then I can stick to the 6 inches of depth and I don't have anybody tell me that I got to be 12 inches, I got to do that type of thing. But all of that's 30 volts or less, and it has to be a listed low voltage lighting system for use in pools, spas, fountains, thing applications like that. Right. By the way, Vince Delacroce is coming in next week, and we will be shooting a lot of footage here in the studio. We'll be doing a podcast with him. He might join us. I believe he'll probably join us for coffee hour on Wednesday. So he'll be live. So he'll be in the studio for that. So that'd be a cool discussion. So make sure you don't miss that next Wednesday. As long as EV Mux works okay and everything works, that type of thing. Um, he'll be there to join us. So that'd be exciting. Have him in the studio. All right, let's get back to here. All right. Now let's go back here. Now, with all of these things right here, I will remind you that this is your depth of cover chart, and it's really easy to follow, but we do have some notes. Okay. And I'll remind you something about notes, right? Notes, these are not informational notes. These are not, I don't have to follow them if I don't want to. These are notes that have to be followed. Okay. So any note that's below a table that doesn't say informational note is very much part of the code. It is very germane to everything that's above it. Okay. So, for example, the reason I bring this up is because digging a trenches, putting cables and conductors and wiring methods in trenches sounds, I'm not going to say it sounds easy because I got an excavator out here, but you can run into challenges. You can run into rock. You can run in Texas. We ran into things like caliche, which is a hard ground. You run into things. So the code understands that and gives some allowances and gives some nuances when it comes to the notes. So don't forget the notes are here. The moment we go to depth of cover, we always sometimes forget that we do have some notes. Okay. All right. So let's go on and look at these notes real quick. All right. Note number one: cover shall be, okay, defined as the shortest distance in inches. I use inches. Okay. So I don't use the SI. I use the inch pound method. That's why it's in parentheses. The SI or metric system in the NEC always comes first, and then the inch pound version comes in the parentheses. You get to choose either or that you want to use, but most of us use the inch pound method here, especially in the US. Other countries do use the National Electrical Code in some countries, and they prefer the metric system. Okay, that's just it. So anyway, measured between a point of the top surface of the direct burial conductor, cable, conduit, or other raceway, and the top surface of the finished grade concrete or similar covering. Okay. So for me and you, a visual is here's your trench, here's your wiring method. You go to the top of that wiring method, whatever it is, not to the trench, top of the wiring method, all measure all the way up to the finished surface. Okay. Now, I will tell you, depending on your finished surface, it can control. Obviously, we just saw it. It can potentially control the overall depth, right? So if it's just ground and it's a direct burial cable like a UF, for example, and I didn't have all those other conditions that would apply, let's say no condition applies, then I had 24 inches of cover, let's say, it's going to be from the top of the UF cable to the finished grade, okay? Now, in that case where it was 120 volt GFCI protected 20 amps or less branch circuit, then it was 12 inches of cover. There'd be 12 inches from the top of the UFB to the finished grade. Okay. And so that's how you would make sure you have the depth of cover. So don't just go putting a trade size 2 raceway in a trench and think that, okay, it's got to be 6 inches of rigid. And I dig a 6 inch trench and I throw a 2 inch or 2 trade size raceway in it and then think I'm done and have an inspector come out and fail you because the depth of cover was 6 inches from the top of the wiring method to the finished grade, not the overall trench itself. So most people get that wrong when they look at the table that way. All right, next. Raceway is approved for direct burial only, where concrete encasement shall require a concrete envelope. Okay, so if I'm going to use a raceway and I'm going to direct burial, and it's going to have encasement in concrete, then I can do that. Okay, so raceway is approved for direct burial only where concrete encase shall require a concrete envelope not less than 2 inches thick. Okay, so you'll see another example where I can use 2 inches in a note in case I hit rock or something like that. Okay, all right, so there you go. Next is just notes to be aware of. 3, it says a lesser depth from the table shall be permitted where cables or conductors rise. Okay, so they've got to obviously have to come up from below. Okay, so it's a no-brainer. It's got to transition up, right? It says, so a lesser depth shall be permitted where the cables or conductors rise from terminations or splices or where access is otherwise required. Okay. All right. So basically, what we're saying here is that at some point, those raceways underground have to turn into a junction box, whether it's a handhold box in the ground or whether it's transitioning out of the ground. At some point, that cover is going to be reduced because it has to get up to either to make splices or to get up out of the ground. I mean, it's inevitable, right? So the code understands that and it's allowing for that application. Now it says where one of the wiring methods types listed in columns 1 through 3 is used. Okay, so just to recap, one is to be direct burial cables and conductors. Column 2 is rigid metal conduit and intermediate metal conduit. And column 3 is EMT, your PVC, that type of thing. All right, so that is those 3 columns. Okay, just so we know what we're working with. It says where one of the wiring methods types listed in column 1 through 3 is used for one of the circuits types in column 4, column 5, the shallowest depth of burial shall be permitted. So what does that mean? Well, remember we had these tables right here that said, let's example here, 24 inches right here, 6 inches, right? Well, if I've got this circuit right here, remember what I said earlier about making sense? Okay, so here's where we're catching up and making sense. It says where this right here is being used, but it's being installed in one of these, okay, whichever yields the lesser value in cover can be used. Okay, so I get to take advantage of that EMT or that rigid or that intermediate. So if I have column 4, column 5, and I'm putting it in one of the wiring methods or applications that are in column 1, column 2, column 3, if that yields, for example, if that yields a lesser cover requirement, then I get to go with whatever the lesser is. Okay, that type of thing. That's all that's saying. All right, and let's see here. Number 5, it says where solid rock prevents compliance with the cover depth specified in this table. In other words, I hit rock. I hit something and it doesn't allow me to go down. It says the wiring shall be installed in a metal raceway or a non-metallic raceway permitted for direct burial. Okay, so I would think all those PVC Schedule 80s, Schedule 40s, and all that are rated for direct burial. Okay, and it says the raceway. Okay, so I can use metal raceway or a non-metallic raceway. Okay, it says the raceways shall be covered by a minimum of 2 inches of concrete extending down to the rock. Okay, so what is that saying to us? That's saying, okay, look, so something may say in here that it has to be 12 inches of cover, but I can't get 12 inches of cover because I hit rock. Okay, well, this is saying, all right, if that's the case, then if you put it in a metal raceway, if you put it in a Schedule 80 or Schedule 40 PVC raceway, then I will let you put it as long as you encase it in 2 inches of concrete. And that's why you had the other statement in here about the envelope of 2 inches of concrete all around. And in this case, I'm going to let you have a reduced cover. But the trade off is you're going to have to mix up the concrete. You're going to have to get it so that I have the 2 inches of concrete around and put it in there. Okay. All right. And then lastly, number 6, let me see if I can get back to the code. Here we go. 6, it says direct buried EMT, electrical metallic tubing, EMT, shall comply with 358.10. Okay. 358.10 is, and of course, that's going to probably have something to do with the corrosion protection on it. So let's see here 358.10, use is permitted. 358.10, right here. We'll go there and look. Here we go. Okay. It says in concrete, in direct burial with the earth, in direct burial applications with fittings identified for direct burial. Okay. So you're not just using set screw fittings here. Okay. Or areas subject to severe corrosion were installed in accordance with 310.10b, 10b. Okay. So here, galvanized steel, stainless steel, EMT elbows fittings. Okay, it just says shall be permitted to be installed in concrete in direct contact with the earth or areas subject to severe corrosive influences where protected by a corrosion protection and approved as suitable for this condition. Okay, there's an informational note here that talks about it. Okay, then galvanized, for example, EMT without supplementary corrosion protection extend directly from concrete encased to soil buried. Okay, it's perfectly fine. So a lot of confusion about whether or not you can direct bury EMT. Yes. So the listing on EMT typically, for example, galvanized steel, that type of thing. Now, what you have to be careful with is the different things like the aluminum EMTs. But when it comes to steel, the galvanized steel, it has a protective coating that is sacrificial. It's a zinc coating that's over on top of it. The galvanization process that is protection against corrosion. Okay. Now, installing it somewhere in the country like Arizona where they have severe corrosive conditions, then that's different. Then you need some additional protection, right? And the manufacturers will give that guidance to you. One of the websites you should check out, and you can Google it, is called Steel Tube Institute. Check them out. They have a lot of great resources. They have some folks that are really good. I think Ryan Jackson does consulting for them. So does Joe Andre. Joe Andre is an amazing guy too. He was a NEMA rep with me, but he's a great guy. And they are the experts when it comes to Steel Tube Institute, that type of thing. Okay. All right. So let's get back to 300.5 real quick, and we'll wrap it up. That's just that first portion of it. That's just the cover portion. All right, so now we get past the cover aspects of it, then we just get into the regular applications, correct? Now, hold on there, we're gonna lose TikTok. All right, so let's see here. So wet locations. All right, so now we're still in underground installations. We talked about the depth of cover at nausea. You should never have a problem now with the depth of cover. Wet locations. The interior of enclosures or raceways installed underground shall be considered to be a wet location. That is why the products you use are wet location rated. That's why you can't put non-metallic sheet cable in raceways underground. In fact, you can't put non-metallic sheet cable in a raceways above ground outside. It's still a wet location, right? But that is a wet location. So the products that you use underground, the cables, whatnot, have to be rated direct burial. And if there's single insulated conductors in raceways, then they have to be rated for a wet location. One question I get from people is, what about aluminum conductors? Look, if it's an aluminum conductor, but the insulation is rated for a wet location, no problem sticking it in a raceway underground. No different than USC-2s available in aluminum. That can go directly in the earth. It's evaluated for it. You have to be careful not to damage the insulation. Take a little extra pride in it, because obviously if you damage it and allow moisture to get in there, then the aluminum is going to rapidly break down, and way quicker than the copper will. So it's all about how you install it. Good workmanlike practices, making sure you don't drag it across the ground, those type of things, and damage it. You got to take a little extra care when you're installing wire and cable and things like that, especially in a location or underground application. It says insulated conductors and cables installed in these enclosures or raceways in underground installation shall comply with 310.10c. That's going to tell you about the W, the wet rating, that type of thing, and rated for such. C, underground cables and conductors under buildings. It says underground cables and conductors installed under a building shall be in a raceway. So one of the misconceptions is that you can't. You saw the table. Is that people see that zero and they say, well, I can't run a conductor or a cable under a building. You can, as long as the conductors are in a raceway. And you can also run MC and MI. You saw that in the table. Well, when you get down here, you'll see the exceptions. This tells you what you have to do to be able to run MI. I don't know why you would. That's some messy stuff. But if you want to run MI, go for it. And then, of course, there's the MC. Now, granted, it says listed for direct burial or concrete encasement. That's going to be your PVC jacketed. So the NEC doesn't call out PVC jacketed like that. It just talks about it as MC. Now, the reason it does that is because there's multiple different types of MC. There's smooth, there's corrugated, and there's interlocked. The interlocked is what would be PVC jacketed. The other, like a smooth or even corrugated, many of those are rated so they can go directly into the earth without any covering on it. So there's other different types of MCs that are available. The vast majority of the MC that people buy today is interlocked because it's more cost effective, and we extrude PVC over it, and then that's how it gets a direct burial rating, right? So absolutely, you can run them under a building if you want. Protection from damage. Conductors and cables shall be protected from damage in accordance with 300.5 D1 through D4. Okay, so that's all these requirements right here. So this is where it is protected inside of raceways or cables, and you're going to do that by the depth of it as well. That's one way to protect it. But also, as it starts transitioning out of the ground, number one, emerging from grade. Okay, you got to get out of the ground to get above ground, right? So it says direct burial conductors and cables emerging from grade and specified in column 1 and 4 of table 300.5a. Again, when it says table 1, that was talking about direct burial conductors, right? And that was talking about direct burial cables. That was column 1. And then column 4 was the residential products, like which is typically going to be UFB, but those type of things. So those were the two this is focusing on, because the other wiring methods are usually in a raceway of some type, or an EMT, or a rigid, or an intermediate. So that's why it says it this way. Okay. So it says those wiring methods that are in column 1 and column 4 shall be protected by enclosures or raceways extending from the minimum cover. Okay, so all the way down to the minimum cover distance below grade required by 300.5a to a point at least 8 feet above finished grade. So if it's, for example, coming out underground, transitioning above ground, and it is direct burial conductors, obviously that's got to stay in a raceway. Right? A good example of this would be URD. It's underground, but then when it transitions above ground, what do? You end up putting it into PVC, right? And transitioning it up to the meter or what, same concept. So as it transitions, it needs to be in the protective, one of the protecting allowances. Okay. In this case, we would be schedule 80 PVC would be a way to do it. Rigid, intermediate, all those type of ways would be fine. And it needs to be up to 8 feet above the finished grade. Now it says, in no case shall the protection be required to extend 18 inches below finished grade. So when we're talking about as it goes down in the ground, even though let's say you had a depth of cover which is 24 inches, okay? Well, that protection that's coming as it transitions doesn't need to go all the way down to the 24 inches, okay? It doesn't need to go down below 18 inches, right? So 18 inches is considered deep enough for that protection to transition, okay? Number 2, conductors entering the building. Conductors entering the building shall be protected to the point of entrance. All right. So coming out underground, coming up, entering into the building. It could be that it's coming in underneath and up into the bottom of the building into an equipment room that's maybe centralized in the building. Okay. Well, it's protected all the way up to the point that it enters into the building. And even then, it may enter into switch gear with an open bottom. That's where the conductors will then transition. It could come up into an equipment room and then go into a piece of gear, those type of things. Okay. Service conductors. underground service conductors that are not encased. Okay, so that would be an example of underground service conductors. Let's say from a transformer that is a premise-owned transformer, and now it's coming in and under that type of thing. Or maybe it's coming from a pedestal, and now it's being run by the electrician, and that is coming underground. Those type of things. Maybe it's a URD. Okay, so the underground service conductors that are not encased in concrete and are buried 18 inches or more below the grade shall have their location identified by a warning ribbon that is placed in the trench at least 12 inches above the underground installation. So you got your trench, you've got your depth of cover. Let's just say it's 24 inches of depth of cover. And these are for service conductors only, not for feeders. So I'm not required to put this ribbon if I'm doing a feeder from my, say, my building to a detached structure, and I'm going to be running a feeder. Not required. A lot of people get confused about that ribbon. Not required when it comes to this application. Okay. Only for service applications do you have to put the ribbon in there. So you put your wiring method, your underground service conductors. Okay. And then, and again, I'll remind you that are not encased in concrete. Okay. So this would be raceways as well that aren't encased. So this would be PVC, rigid, intermediate, direct burial conductors, URD, any of that. Okay. It's underground service conductors. It's irrelevant to the wiring method. Okay. That's an important distinction. Okay. And it's not applying to those that are encased in concrete for whatever reason. It's only applying to all the other wire methods that are not encased in concrete. And that again covers the direct burial conductors, or if it was in a raceway that has nothing to do with the concrete encasement. Okay. You got to have that ribbon. So you go to the bottom, you cover whatever your wiring method is up 12 inches, then you put the ribbon in there. Okay. At least 12 inches above the underground installation. So 12 inches, put it at 13 if you want, put it at 14, whatever. It needs to have at least 12 inches of cover, and then I got to have a warning ribbon in there that only applies to service conductor applications. Okay. And there's no graphic here, but okay. Next would be enclosures or raceway damage. It says where the enclosure or raceway is subject to physical damage, the conductors shall be installed in EMT, rigid metal conduit, intermediate metal conduit, RTRC XW, Schedule 80 PVC conduit, or equivalent. This is important because where it's coming up out of grade or emerging, for example, if that area is subject to physical damage, then you might be able to get away with Schedule 40 PVC underground. But once it transitions, for example, above grade, then if it's in an area that is subject to physical damage, then you need to use, if you're going to use PVC, you need to use Schedule 80, not Schedule 40 in that area where it's subject to physical damage. That doesn't mean the portion outside underground can't be Schedule 40. It can be. We're talking about the portion that is subject to physical damage, that type of thing. And also it says or equivalent because they do make products that will fit over it. So somebody might run Schedule 40 up, and that is not going to handle physical damage. So they do make other products that can go over that and add that element or that extra protection, that type of thing. Okay. Splices and taps says direct burial conductors or cables shall be permitted. Okay, so remember that old saying, we all splices typically get done in boxes, right? And so if you're normal electrical, you do wiring, you know that you're going to put your splices in junction boxes, switch boxes, device boxes, or what have you, not just willy-nilly everywhere. However, direct burial conductors and cables that are designed for direct burial shall be permitted to be spliced or tapped without the use of splice boxes. The splices and taps shall be made in accordance with 110.14b. Right? So I don't have any, it doesn't show. There you go. So this is a heat shrink that you can use if you have, this is some UF cable and it's obviously damaged. Well, they do have kits where it allows you to splice it underground to repair this without putting any type of junction box or any type of box there to be able to get access to that. Right? That is perfectly acceptable to be able to do that. Okay. And that's the rule that allows you to do that. All right. Backfill. So, probably as a wiring cable guy, one of the biggest issues that I see when people submit drawings to me or something that I look at is the trench preparation. How you prepare your trench. People just dig it. They leave large rocks. They leave stone in there. All types of things. It's real jagged. They don't prepare the beds properly. All that kind of stuff usually is done haphazardly. So this rule requires, and we'll go look at it. It says backfill. It says backfill that contains large rocks, paving material, cinders, large and sharply angular substances, rocks, okay, or corrosive materials shall not be placed in an excavation where materials might damage raceways, cables, conductors, and other substructures or prevent adequate compaction because it creates voids because of the way the material is sitting. It creates a void in there. Uh, where to prevent adequate compaction of fill or contribute to corrosion of raceways, cables, or other substructures. Okay? Clean your trenches. Now, a lot of the large manufacturers have a procedure. We at Encore Wire and Prismium, I give a procedure when requested on the proper way to prepare the bed. In other words, clean your trench out, put it crushed gravel or put some sand down, things like that. All of this obviously is going to affect your depth of cover, right? So if you don't think about your trench and you're putting down this substrate in order to lay your wiring method on so you don't damage it, unless you really are meticulous and make sure that you don't have any rocks, things like that in your trench, and maybe you don't, and you put it in there. But if you do have a prepared bed, remember all of that is going to affect your depth of cover because you're measuring from the top of the wiring method to the finished grade. Okay, so just keep those things in mind. It says, where necessary to prevent physical damage to a raceway, cable, or conductor, protection shall be provided in the form of granular or selected materials, suitable running boards, suitable sleeves, or other approved means. That other approved means the AHJ may be able, you may be able to work with them on something, but typically this is granular, crushed, really crushed gravel, sand, things like that. If it's really obvious that you're going to have potential damage in there and they can't remove any of the large rocks or whatever, it's a really rocky area, that type of thing, really jagged. This also, by the way, goes for transitions. So when you're digging a trench and you're turning a sharp turn, that sharp angle, you do not want your cables or direct burial conductors or anything to wrap sharply around that edge. As the ground compacts, it could rub against the sharp edges as things compact, and that could be a damage point. So all these things you know that you should take into consideration as an installer, making sure your trench is prepared properly. Now, if you're running through the residential backyard, probably going to not have any issue with any of this. But in a lot of big projects, you may have these issues that you need to be aware of. Raceway seals. Okay, now conduits or raceways through which moisture might. Okay, now, I kind of hate the word might, but might. It's kind of saying, is it plausible? Yeah. If it's there, there's an annular space, and yeah, it's plausible that moisture might contact live parts, shall be sealed or plugged on either or both sides. Now, this is one thing that I see from people a lot is that when they come into a piece of equipment and they're going from the outside in, they seal both sides. They seal the inside and they seal the outside. You really don't have to seal both sides. You have to seal either outside or inside. You just got to keep it from being able to get into the equipment where the live parts are, right? So if you want to seal it from the inside, that's fine. You want to seal it from the outside? That's fine. Polywater makes some great sealing products. Okay. If you're interested in those type of products, they make a really top of the line sealing type stuff. So check out Polywater. A lot of people use things like a duct seal, things like that in order to clear. That's usually more for air, okay, than it is for moisture, that type of thing. So just pick your sealant wisely. Um, A lot of times people will also seal this outside where the conductors come into the raceway so that moisture can't come up and into it. So they'll seal it out there, for example, with like a silicone material or something that's going to fill that void, that type of thing. Okay. Now it says spare and unused raceways shall also be sealed. Okay, so you have you seal in the ones where the cables or the conductors come into an enclosure, for example, and you might get moisture that could come through. Um, if you have spares or unused raceways, they have to be sealed as well. Okay, so keep that in mind. Sealants shall be identified for use with cable insulation, conductor insulation, bare conductors, shields, or other components. Okay. So you're not just grabbing anything. You want to make sure your sealant is not going to be detrimental to the cables insulation, conductor insulation. It's not going to have a reaction to any bare conductors or whatnot. If you have any like equipment grounds coming through, or if you have any bonding jumpers that are bare coming through, or something like that, you want to make sure it's not going to have adverse condition. Now, you don't reach out to the wire and cable manufacturer. Okay, I'm gonna give you a little tip when it comes to when you're worried about how wire and cable is going to react to something. You got to go to the manufacturer of the product that you're using, not the wire and cable folks, because we don't test our products on all those different types of things. They're required to test, for example, their products. If it's for use with wired, they want to test to make sure it's okay with PVC. So they'll test it on generically on PVC. We can't test it on all the manufacturers of their products, but all of the wire and cable folks, since products have to be listed, it's better for them to test their product on wire and cable than the other way around. So reaching out to a wire and cable manufacturer, for example, to find out whether or not this product is detrimental to it is not going to work. You need to contact the product manufacturer of whatever that product is that they're using, not the wire and cable, that type of thing. Okay? Save you a little step there because we're going to end up telling you, no, we can't help you, that type of thing. Bushings. All right. Bushings. Here it says a bushing or terminal fitting with an integral bushing opening shall be used at the end of a conduit or other raceway that terminates underground where the conductors or cables emerge as a direct burial method. So, for example, and I don't have a picture, but you say you got a meter and you're stubbing up to the meter and you're coming down underground, you're coming down, let's say 24 inches of cover, you're coming down, you're turning at the end. Okay. At the end of that uh, wiring method down there, it needs to have a bushing or terminal fitting, maybe a bell end or some smooth end or whatever, with an integral bushing opening shall be used at the end of the conduit or other raceway that terminates underground, where again the conductors or cables emerge as a direct burial wiring method. So as it comes out the end of the wiring method, underground, you're transitioning from underground to above ground. That in there, that conduit or termination has to have a bushing on there. Okay. Now it says a seal incorporating the physical protection characteristics of a bushing shall be permitted to be used in lieu of a bushing. Okay. So this could be some type of seal that goes on the end. Okay. Or if you're putting some type of sealing in the end of it, like a polyward and sealing it. Okay. Then the way that it centers the cables or centers the conductors, then that can be considered adequate as well. They also do make sealing ends as well that would meet that in lieu of putting a bushing on it. Okay. So if you have a seal and it incorporates in some design the physical protection characteristics of a bushing, if that's inherent to it, then you're okay. So it's kind of built that way. Otherwise, you need to put a bushing on the end of that conduit or raceway so that it protects the end, that type of thing, or those conductors as they emerge underground. Okay. Now, conductors of the same circuit. All right. Okay. So it says all conductors of the same circuit and where used, a grounded conductor. And the reason it says this, because you could have systems that don't have a grounded conductor. Okay, we take a grounded conductor to the service, but you could have systems where you're not using a grounded conductor. But where you do have a grounded conductor or neutral, okay, and the circuit conductors and the equipment grounded conductors, they shall be installed in the same raceway or cable, or shall be installed in close proximity in the same trench. Okay. Okay. So close together in the same trench, raceways, close proximity, those type of things. All right. You have an exception. Then this exception right here says conductors shall be permitted to be installed in parallel in raceways, multi-conductor cables, or direct burial single conductor cables. Okay. Each raceway or multi-conductor cable shall contain all the conductors of the same circuit. Okay. Include equipment grounded conductors. Each direct burial single conductor cable shall be located in close proximity in the trench, means putting them close together so that we don't create any induced currents and we don't create induced heating effect. Okay. Expanding and collapsing magnetic fields, keep them in close proximity. Okay. That type of thing. And we do have exception number 2. This is very unique. So y'all have all seen us talk about raceways in parallel above ground, right? Where we have in raceway 1, we have ABC and a neutral. And in raceway 2, ABC and a neutral and equipment ground. And in raceway 3, you have ABC. So they're evenly the same in every one. Well, you are allowed to isolate the phases in an underground installation where you have all A's in one raceway, all B's in one raceway, all C's in one raceway. Most people don't do it that way, but you can do that underground, but you have to follow this exception. And here's what it says: it says isolated phases, polarity, grounded conductors, and equipment grounds. Okay, basically, it's just saying that all the A's in one raceway, all the B's in another, all the C's in another, that type of thing. Um, all the equipment grounds in another. All of that can be isolated. It shall be permitted to do this in a non-metallic raceway or cable, or a cable with a non-metallic covering, or a non-magnetic sheathing in close proximity where the conductors are paralleled as permitted in 310.10g, which is your paralleling rules, same characteristics, all the A's, the same conductive materials, same insulation, terminated the same way, the same length, all those parallel requirements, okay? And where the conditions of 300.20b are met. And that is if they happen to pass into an enclosure, and the enclosure is a ferrous type of enclosure that you basically, they come in and act as one. Okay, so basically you have all your knockouts and you actually connect a line between all of them. So it basically acts like one big KO, even though there's maybe separate KOs. That is what you do if you have a wall that's passing through that is ferrous, like a steel box. Okay. If you have a insert, and I've seen some of these boxes where if there's an insert that is non-metallic, okay, and it is non-ferrous, then you don't have to worry about that. You can come in 4 separate entries. But if it goes through the sidewall of a ferrous metal enclosure, like a steel enclosure, then you have to follow the rules in 300.20b. And in order to reduce this induced currents in this expanding and collapsing magnetic field, it creates this heating effect that could damage the conductors and destroy the actual connections with these non-metallic wiring methods. Then you have to make all of those openings act as one. And that's where you've seen it, where you have multiple KOs and then they cut a line between each one of them. So there's separate entries, but they act as one big opening. That's what you have to do if the wall that you're passing through happens to be a ferrous metal or steel type of enclosure. Now, if you're coming into the bottom, for example, of a bottomless gear, then you don't have the same effects of 300.20b, but you do run all of your raceways is in close proximity, and you'll be okay there. Only applies to underground applications and only in a non-metallic raceway. Any other time, then I'm going to want to have parallel sets run ABC, 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 for example, in separate raceways. Okay, makes sense. Okay. Next is earth movement. All right, so earth movement, very common. Many areas of the country, we had ground heave, frost heave. We have areas in the country where there's a lot of seismic activity. You usually will probably already have some type of rule in place in your jurisdiction. The AHJs might already be familiar with. You might have already had to do this. You've already familiar with putting expansion joints so that it compensates for this movement, things like that. Now, this is specific where it says right here, it says earth movement. It says where direct burial conductors, raceways, or cables are subject to movement by settlement or frost. Okay. Direct burial conductors, raceways, or cables shall be arranged so as to prevent damage to the enclosed conductors or to equipment connected to the raceway. All right. Now, this has an informational note. This is good information. A lot of times people will put what's called the ability for the expansion fitting in there. Okay. And in your jurisdiction, they may require it already. And it says, informational note says, this section recognizes S loops in underground direct burial cables and conductors to raceway transitions, expansion fittings in raceway risers to fixed equipment, and generally the provision for flexible connections to equipment subject to settlement or frost heaves. So there's many ways to do this. Okay. You could take the conductors and form in the ground underneath it before entry. You could form an S loop, and that will allow movement. And so when the conductors move, it will not put any undue stress on the terminations. Okay. You can put that S loop in there. Okay. Most people will just put an expansion fitting in there so that if it moves up and down, the raceway allows for it to have slight movement, that type of thing. Okay. And that's not going to be a problem either. It allows a little bit of movement up and down. Okay. All those type of things. You'll know your jurisdiction and whether or not you have to do that. Okay. Lastly is K, and K is for directional boring. It says cables or raceways installed using directional boring equipment. And by the way, not every wiring method can be used with a directional boring. So you have to make sure that once you determine you're going to use directional boring, then you're going to follow the manufacturer's recommendations from the directional boring machine manufacturer, and then look and talk to the manufacturers of the wiring cable to find out what products allow for use with directional boring. Okay, that type of thing. All right. So again, and it says it shall be approved for the purpose. Okay. Cables and raceways installed using directional boring equipment shall be approved. That means the AHJ needs to know what product you're using, and they're the ones that are going to approve it. But you need to make sure that that product will work with a directional boring machine, that type of thing. Okay. A lot of the directional boring machines are set up to use like a cable in a conduit type of scenario. Okay. So it's on a big reel, that type of scenario. Okay. All right. All right. Let's see here. What is Jonathan says? Only one neighboring county I work with requires an expansion fitting, but I always, after learning from you last year, yeah, put one in. Better safe than sorry. They're not that expensive, and at the end of the day, the last thing I want to do is go back and have to come back, especially if I'm in an area that I know has a lot of movement, a lot of frost. If I'm anywhere that is north of, kind of go to the top of Texas and draw a line across the country, anything north of that, it's a must. Anything below that is less issues with the heave. But again, work with your local jurisdiction, that type of thing, and that'll get your best thing. Okay. All right, folks, that's it. Kind of a mixed bag of lessons today. It was kind of all over the place. I will thank EV Mux for that. Again, we'll do no drawing today. I'm sorry. There's just I don't show very many people in the room, so we'll just go on and just chalk it up to a really messy broadcast. It started out bad and ended that way. We might look at switching away, but EV Mux usually doesn't have a problem. It's very limited, but they have absolutely had a problem today. Now, it might be because they added an update. So they did do an update. So that could be the reason, but I'll give them a benefit of the doubt. All right. All right, folks, till next time, stay safe. We'll catch you next Wednesday. Vince will be our special guest, and we'll talk pools, spas, and hot tubs. So bring your questions for Vince and myself next week. It's a must watch. You must be here next week because, again, he's going to be in the house and we'll be answering questions if you have them. So come and join Vince and me next week on Coffee Hour. Till next time, stay safe. God bless.